No matter what they say, it should never bring you down. It should never bring you down. You should know who you are. You should know who you are. Know who you are. Are you the son of the soil? When it comes time to shine, would you shine? Or would you crack? Would you crack? Would you crack? Or would you crack? Would you crack? Good evening, ladies and gentlemen. Good evening. Welcome to the Intelligence Black Paper Soliloquy. In this session, I'm going to do an informal reading of the Intelligence Black Paper, which I have worked on for quite some time now. And I figured if I went through the paper itself and sort of explained a bit of my thought process, it might help others digest it more efficiently. So to begin, I will just first say that so the black paper, the purpose of the black paper is to essentially create or essentially define a North Star for our perception, for humanity's perspective when it comes to understanding our universe, understanding where we fit in within the hierarchy of dimensions. So what I decided to do was I decided to create a sort of a DAO-like structure using the Ethereum network and using unstoppable domains and using ipfs, where I hosted the paper in an immutable manner so that anyone around the world can have access to this and be able to use it as their sort of foundational model when it comes to systems development, systems optimization, etc., etc. So I'm going to first begin by reading here the introduction of the Intelligence Black Paper. The Black Paper itself is divided into 16 parts, short parts, of course, just so that it doesn't get too inundating to understand. So, so the introduction. Here we go. Hello, universe. Welcome to the Intelligence Black Paper. My name is Triangle Infinity Circle. On planet Earth, I have many discrete names. I emerged in West Africa from a region called Cameroon as the son of Koso Ngu. I hope that something from this paper inspires you. For centuries, science and mysticism have attempted to answer the deepest questions concerning nature. Some of these questions include what is nature? What is consciousness? What is intelligence? What are intelligent systems? How do intelligent systems interact? Many schools have emerged within the scientific community seeking to discover a fundamental law underpinning physical phenomena. Unfortunately, many of the formalizations fall short because of physical theories um, require boundaries and strict generalizations. So the question we're going to ask here is, does a boundary exist that limits physical theories and the ability to universally generalize? If so, how do we transcend this boundary? How do we reconcile physical phenomena and non-physical phenomena? Can we unify infinite and finite systems essentially? So this intelligence black paper aims to answer these age-old questions about the blueprint of nature. It proposes a framework with the rules of the universal generalization. So, how to read this paper? Please approach this paper with an open mind, of course. The exploration is discipline agnostic, meaning we blur the lines between traditional disciplinary boundaries. At its core, this work is artistic. And on the journey to solve this problem, we utilized mathematics, creativity, and a little bit of imagination as our main tools. So the next part that I'm going to read here is called Section 2, The Theory of Everything. And here I'm going to introduce to you guys sort of the context for me even, trying to, solve this problem or even write this paper. What's the motivation behind it? What led me to this point? So page 4. It's titled Theory of Everything. So historically, academics have received prestige and occasionally prizes for their discoveries. And some of these discoveries were impactful enough to transcend academic institutions and make it into popular culture. Examples were Einstein's famous energy mass equivalency equation and Schrodinger's wave function equation for a quantum mechanical system. We believe that the equation of intelligence presented in this publication is as impactful as the aforementioned equations. To make the dissemination of this knowledge interactive, we decided to not only publish the academic work, but to also create this black paper digital asset that is domain agnostic, meaning that the asset holds its value regardless of what platform it's hosted on. So the asset is backed by the fundamental, immutable abstraction equation of intelligence outlined in the publication. So next, I'm going to read to you guys page 5, called Genesis Intelligence. And here I'm just going to compare the sort of the philosophy or the theory that we're presenting here as the genesis, and I'm going to compare it to a blockchain, for example, how blockchains have genesis block. And theoretically speaking, if we define a genesis block, a philosophical genesis block, what is that going to be? So that's sort of what I go into in the next part here. So Genesis intelligence. So the Genesis block of a blockchain defines the first block and also includes the rules for the blockchain itself. The rules in that Genesis block outlines the rules of interactions and evolution of the blocks and the blockchain. The equation of intelligence presented in this publication is proposed as the Genesis block of nature. If intelligence is the zeroth block of our universe, it holds the organizational principles for the rest of the universe. Thus, the implications is that material, as well as other derivative emergent phenomena, could just be expressions of this fundamental abstraction, of this fundamental abstract intelligence. This means that from this formulation, all other natural laws could be derived. And from a physics perspective, everything in the universe, from fundamental particles to biological systems, could be explained by this simple new abstraction, simple new formalization. So that ends that. I kept that part short. The next here, I'm going to read to you guys page 6, which is stability and scalability, where I just go a bit into that and I elaborate on how we could, you know, how we have to account for those two fundamental variables when we're trying to optimize the system. So stability and scalability. So in neural networks, the activation function of a node decides on when to activate the function that defines the output. This is akin to the genesis block of the blockchain, as aforementioned. This block contains the intelligence that defines how the blockchain grows. For example, Bitcoin. Bitcoin's blockchain is a network that processes transactions using a proof of work algorithm that makes it computationally costly to add new blocks, but not as costly to verify them. This constraint allows for the relative stability of the blockchain. These two constraints are represented by Bitcoin's average block creation time of X minutes and the block size limit of X megabytes. And X is just arbitrary, of course. So these constraints create a limitation on the blockchain itself that causes divergence on the chain, as new rules of forks have to be introduced to maintain the stability of that chain. This limitation on the blockchain um, can be compared to what is known as the Bitcoin scalability problem, which is what we're currently dealing with today with Bitcoin, as an example. Um, so this limitation is due to the constraint of the finite computational memory. This computational limitation is a limitation that constrains our ability to compute infinite algorithms or compute infinite problems. So finite algorithms are constrained computationally by space complexity and time complexity. Um, um, and in this case, if we're going to use the blockchain as an example, space complexity will denote the block size, as I mentioned earlier, and time complexity will denote the block creation time. So, as you can see, with those two fundamental variables being optimized, being optimized, the blockchain itself changes because of that. This means that space complexity and time complexity uh, would incrementally have to be optimized to make the blockchain more stable as it grows in complexity. So, an example is as the Bitcoin network grows, it gets slower. Um, that's a complexity problem right there. The Bitcoin scalability problem, which is why Ethereum and all the other derivative blockchains emerge trying to solve this problem. Is when when complexity increases, how do we account for the how do we stabilize the blockchain? So guys, I'm going to pause there for now. I've been talking for a while. I'm going to pause and I'll read page 8, which is called the intelligence standard. And that's just a way of essentially reorienting how we I guess rate systems. My goal is to really introduce a way to rate systems, right? No, there's a gold standard. I think there should be an intelligence standard. An intelligence standard would be essentially a way to measure the completeness and consistency of a system, to account for the fact that the system will be interoperable or will be able to work symbiotically with all other systems around it. That's how we account for the interaction variable. So I'll pause for 1 second. Okay, back. Okay, so the intelligence standard. So the equation presented in the publication is equivalent to the gold standard or other historical anchors, where monetary value was pegged to something with intrinsic value to avoid the perils of inflation and deflation. In essence, because the equation presented in the publication is the